Okay, yeah. So I'm Troy Lee. I'm a mathematician at NTU.
And my name is Anne Chong, and as a background, I'm an actuary. So my interest in this whole hackathon was really about getting data and seeing what data's out there.
And so we looked at using weather data for dengue predictions.
Just stop. Guys, silence please. So whenever you make noise, we reset the clock and we give the team more time. So noise is doing yourselves a disservice. So guys, you can start all over again if you want to, or you've got more time.
Okay, thanks. Okay, so I don't know if you've noticed, but this has been a record year for dengue. So there's over 4 times as many cases this year as last year. And here's another virus that's borne by the Aedes mosquito. Last year there are hardly any cases at all. This year you have some weeks with over 40 cases.
So just a quick note on our data. We got our data sources from the NEA website, gov.sg.
Yeah, it's from the data.gov.
And also we looked at one map.
So the NEA actually already uses temperature as an indicator when to deploy manpower on the streets. So if the ambient temperature is more than 27.8 degrees Celsius, they put more feet on the ground.
Okay, so basically what I wanted to look at was just any patterns in the data, and Troy was interested in dengue, so we kind of combined forces and looked at what the weather and what dengue incidence cases were telling us. So if you go back here, see the red line and how it stops? So my interest is in how that red line will look on those 2 cases going forward. So our goal then was actually, we thought that we could come up with risk factors or indicators of dengue incidence.
So we looked at additional weather factors like, well, for example, rainfall is a clear factor that's going to affect dengue, right? So here you can actually see some spikes in the rainfall around week 12 to 13, and that seems to actually be spiking the dengue like almost 3 months later. So this is quite interesting because you have a lot of time to prepare and put more feet on the ground when you have these spikes for the future.
But then there are other factors which potentially could also influence. So these are patterns that we took from real-life data. If you look at how they correspond, so the gray ones are the factors that we pulled up, and the blue and red lines, you can tell, are the dengue and the chikungunya incidence rates for 2012 respectively. So first graph up there is mean temperature, second, surface wind speed, third, relative humidity, fourth, mean amount of cloud cover.
Okay, so obviously we couldn't analyze all this data in a weekend, but there are actually quite a large academic body of work on this, and they've developed models, and it does seem to have predictive power. And they do observe this phenomenon that the predictive power is like 3 months in advance. So you do have quite a lag time in order to prepare.
So what we thought that, so right now it's just a presentation of our findings, but going forward, to take this forward, you could possibly try to implement and possibly improve on the predictive models that have been in place. And lots of you here have been building wonderful apps, and it's possible that you could incorporate this kind of information into your apps.